All right, let's start with a bit of a riddle. What on earth could a giant wind turbine, one of those things spinning hundreds of feet up in the air, possibly have in common with a 400-ton mining truck? I mean, these things are beasts, heavier than a jumbo jet. They operate in completely different worlds, under totally different kinds of stress. But believe it or not, they share a critical vulnerability.
And the answer is something so small, so simple, you'd almost never think about it. It's the humble nut and bolt. You see, when just one of those little fasteners gives up and comes loose, under all that relentless vibration, heat, and stress, the results can be absolutely catastrophic. So this is the story of how you go about reinventing one of the oldest, most fundamental pieces of technology we have.
Today, we're going deep inside the QSAP X1. It's a fastener system that was engineered from the ground up to solve this massive problem that plagues some of our most demanding industries. And let me tell you, this is not just a better bolt. It's a whole new way of thinking about how we hold our world together.
So, to really get why this matters so much, we first have to wrap our heads around the scale of the problem. What really happens when one simple bolt decides it's had enough?
Get this, unplanned downtime from a single loose bolt can cost a company more than $500,000. In heavy industry, this is no small thing. For a huge mining operation, a failed bolt on a conveyor can shut down the whole production line for hours. On a wind turbine, it could compromise the entire structure. And on a railway, well, that's a massive safety hazard. So at best, it's a giant financial headache. At worst, it's a catastrophe just waiting to happen.
And that is exactly the challenge the QSAP X1 was built to solve. So how do you even begin to reinvent something as fundamental as the nut and bolt? Well, you start by rethinking every single part of the system from scratch.
And here it is. This is what that reinvention looks like. What you're seeing here isn't just a bolt and a nut you'd find at the hardware store. No, this is a complete engineered system. Every single feature, from the shape of the threads to the materials literally hidden inside, is designed for one purpose and one purpose only: to never, ever come loose on its own.
The real genius of the QSAP X1 isn't just one thing. It's the combination of 3 core patented ideas that all work together to fight the very forces that cause every other bolt to fail.
And this gives us a peek into the heart of the tech. It's so cool. On the left, you can see the unique shape of the threads. That's what creates what you can think of as a one-way grip. And on the right, that incredible-looking lattice structure, that's actually an internal shock absorber hidden right inside the bolt. Let's break down what these actually do.
Okay, first up, the threads. Your standard bolt has symmetrical V-shaped threads. The QSAP X1 is different. It uses asymmetric threads. So the side that bears all the load has a really steep angle, somewhere between 25 and 35 degrees, but the other side is much shallower, just 10 to 20 degrees. It's a brilliant design that basically creates a one-way street for force. It makes it pretty easy to tighten, but that super steep angle creates immense resistance against any vibrations trying to shake it loose.
Second, tucked away inside the bolt is this amazing 3D microlattice. It's made from a special high-entropy alloy, which is just a fancy way of saying it's a metal blend known for being incredibly strong and resilient. It acts like a tiny, super strong spring or a shock absorber. So when a big impact or a harsh vibration hits the bolt, this core actually compresses and just soaks up that energy, stopping it from ever shaking the nut loose.
And the third innovation is actually in the nut. It's a bimetallic ring that uses a shape memory alloy, one of those smart materials that can change its shape with temperature. You can think of it like a tiny, powerful thermostat. As the temperature swings wildly in these harsh environments, the ring actively expands or contracts to maintain the perfect clamping force, and it works flawlessly from a bone-chilling -60 all the way up to a scorching 250 degrees Celsius.
Now look, these are all brilliant ideas on paper. But how do you prove they're going to work in the real world before you even make a single one? Well, you put the design through what is basically a digital torture chamber.
Using a process called finite element analysis, or FEA, the engineers could simulate years and years of abuse in just a few hours. They threw every force, every temperature extreme, and every vibration you can imagine at the digital model to see if the design would actually hold up. And this right here, this is one of the most brutal tests of them all. It's a simulation of the Junker test, which is the industry gold standard for vibration resistance. This machine has one purpose and one purpose only: to violently shake a joint sideways until the fastener just gives up and loses its clamping force, what engineers call its preload.
And the results, they're just staggering. A standard high-quality bolt, after 50,000 cycles in this test, can lose over 80% of its clamping force. I mean, for all intents and purposes, it's loose. The QSAF X1, under the exact same brutal conditions, lost less than 5%. That's the difference between certain failure and absolute, rock-solid reliability.
And it wasn't just about vibration. This digital gauntlet proved the design could handle everything. Extreme temperature swings, check. Massive 50G shock impacts, no problem. It was even rated to survive over 10 million load cycles, which means it has an incredibly long life even under constant stress.
So, let's recap. It's stronger, it's smarter, it's way more reliable. That all sounds expensive. And well, it is. Let's not beat around the bush, let's talk about the price. At high-volume production, a single QSA X1 system costs about $145. Now, I know what you're thinking. When you can buy a standard industrial bolt for just a few bucks, that number can cause a bit of sticker shock. But the real question is it actually the expensive option?
Well, that perspective completely changes when you look at the real cost of a connection. See, the true cost isn't the price of the bolt, it's the cost of failure. When one single unplanned shutdown can cost a mine over $500,000, that $145 investment suddenly doesn't just look reasonable, it looks like one of the smartest decisions you could possibly make. And this isn't just some cool concept or a lab prototype. The QSAF X1 has a clear, aggressive plan to get this technology into the hands of the industries that need it most.
This 36-month roadmap lays out the whole strategy, broken into 4 clear phases. They've already blown through Phase 1, proving the concept with simulations and filing the patents. They're now deep into physical validation and certification with their first pilot customers, and the plan is to launch commercial sales and then scale up to international distribution, all within the next 3 years. And this really brings us to the most crucial takeaway. When you're dealing with multi-million-dollar machinery where a single loose bolt can bring the entire operation to a screeching halt, the value proposition is just crystal clear. As the developers themselves put it, preventing just one failure can pay for upgrading every single fastener on an entire machine. So the question then isn't, can we afford this bolt? It's, can we really afford not to?